In this video, we will be relating rational exponents to radicals. Let's look at some patterns involving rational exponents. On the left will be an operation with radicals. On the right will be an operation with exponents. On the left we have root 3 times root 3. Using the multiplication property of radicals, this is root 3 times 3, which is the square root of 9, which we know to be 3. On the right hand side, we have 3 to the 1/2 times 3 to the 1/2. Recalling our product of powers rule in the upper right hand corner, we get 3 to the 1/2 plus 1/2 because we add the exponents because they have the same base. 1/2 plus 1/2 is 2 over 2, which is 1, and 3 to the 1 is 3. So these operations appear to be equivalent. It also looks like the root of 3 is equal or equivalent to 3 to the 1/2. So the square root of 3 equals 3 to the 1/2. Recall that the index for the square root of 3 is the phantom 2, and the exponent for the radicand 3 is the phantom 1. Notice the placements of the 1 and the 2. Let's look at more patterns. On the left, we have the cube root of 4 times the cube root of 4 times the cube root of 4. And for exponents, we have 4 to the 1/3 times 4 to the 1/3 times 4 to the 1/3. Let's do the math on the left-hand side with the radicals. So using our multiplication property for radicals, we get the cube root of 4 times 4 times 4, all under the radical sign. We end up with the cube root of 64, and we know that to be 4. On the right-hand side, using our product of powers rule, we know we can add the exponents. So 4 to the 1/3 plus 1/3 plus 1/3, giving us 4 to the 3 over 3, which is 4 to the 1, which we know to be 4. So it looks like these operations are equivalent. So it also means that the cube root of 4 is equivalent to 4 to the 1/3. Recall that the exponent for the radicand 4 is a phantom 1. So here's our conclusion. It looks like the nth root of a is equal to a to the 1 over n. Let's do some practice. Evaluate each power without using a calculator. 125 to the exponent 1/3, according to our rule in the upper right-hand corner, can be written as the cube root of 125 to the exponent 1. 125 is a perfect cube. So this can be written as the cube root of 5 times 5 times 5. And the cube root of 5 times 5 times 5 is 5. Let's look at B. 0.36 raised to the exponent 1/2. 0.36 is 36 100ths. So that's 36 over 100, all raised to the exponent 1/2. According to the rule in the upper right-hand corner, nth root of a equals a to the 1 over n. This is equal to the square root of 36 over 100 to the 1, which is really just the square root of 36 over 100. 36 and 100 are perfect squares, so that's square root of 6 over 10 times 6 over 10. So that means the answer is just 6 over 10, which can be simplified to 3 over 5 if we divide both numerator and denominator by 2. Let's look at C. Negative 27 all to the 1/3 is really, according to the rule in the upper right-hand corner, the cube root of negative 27 all to the exponent 1. And this is equal to the cube root of negative 3 times negative 3 times negative 3, which of course the answer is negative 3. For D, 9 over 49 to the exponent 1/2 is really the square root, and I'll put the 2 in there now, of 9 over 49 to the exponent 1, which is really the square root, no need for the 2 now, of 3 over 7 times itself, 3 over 7. So our final answer is 3 over 7. Please proceed to the next video in this lesson, and thank you for viewing.